Hi friends, welcome to my channel Ophthalmology Academy. Today we are going to discuss aqueous outflow pathways. As you know, aqueous is the fluid in the anterior segment of the eye and which is being continuously formed and continuously drained. Aqueous formation is a process which starts in the ciliary body. Here I am going to give you an overall sketch of the various structures which function in the aqueous production and aqueous outflow. This is a sketch of the anterior segment of the eye with cornea shown. This is the anterior chamber, lens, and then iris. These are the veins. I will be explaining them. Coming to this is the hole is the aqueous chamber. This will be the angle of the anterior chamber. This is the anterior chamber. This is the iris, and this the space behind the iris and in front of the lens is the posterior chamber. Combine this posterior and anterior chamber, we call it as anterior segment. This is the lens attached by the zonular apparatus to the ciliary body. This is the ciliary body. This oval shaped channel is Shallum's canal, and this yellow mottled in brown is the trabecular meshwork. From here lead these veins into the outer vein, that is the episcleral vein. Now at any given point of time, aqueous is being continuously formed. This posterior segment contains 0.06 ml of the aqueous and is in direct communication through the pupil with the anterior chamber, which contains 0.25 ml of aqueous. Aqueous is produced in the ciliary body through process of diffusion, ultrafiltration, and excretion. I am not going into detail of that. That's a separate topic. As the aqueous is produced, it moves forward through these convolutions, which are called as ciliary processes, which are the main site of aqueous production. This aqueous moves into the posterior segment and then flows through the pupil into the anterior segment. From anterior segment, it moves to the angle of the anterior. It moves through the pupil to the anterior chamber, and then from anterior chamber it flows into the angle of anterior chamber. Usually this whole process is a passive one, aided by blinks and ocular pulse, but the main resistance to aqueous outflow occurs here at the inner wall of the Shallum's canal, at the internal at the internal junction between the Shallum's canal and the trabecular meshwork, because the pores are smallest here, so obviously there is higher resistance. So the main rate limiting factor in aqueous outflow is this inner wall of the Shallum's canal. Then from Shallum's canal, the aqueous flows through these channels. One is directly going to the episcleral vein, another is going through a plexus. These directly going veins are called as aqueous veins, and this is the intrascleral plexus, intrascleral aqueous vein plexus. Both of them then directly drain into the episcleral vein, which continues as the anterior ciliary vein. Now here's an important point, that earlier it was thought that since the UL pressure, the pressure in these veins is lower than the IOP, this aqueous flows passively into the episcleral veins. but now it has been found to be wrong. Actually, there operates a biomechanical pump here at the trabeculocerebellum junction, which aids in the unidirectional flow of the aqueous from anterior chamber to the aqueous veins. This whole process is the trabecular pathway of aqueous outflow, which drains about 75 to 85% of the aqueous. Now the question arises, where does the rest of the aqueous go? The rest of the aqueous, roughly 20%, moves out of the posterior segment into the ciliary body. From ciliary body, it moves into the suprachoroidal space, which is the space between the choroid and the sclera. So it moves in the suprachoroidal space. From the suprachoroidal space, it moves into the choroidal veins. This forms the total pathways of the aqueous outflow. So there are actually two pathways. One is the uvoscleral outflow, that is via the ciliary body, and another one is the trabecular, that is the conventional flow, that is via this pathway. Hope that has helped you. Like and subscribe to my channel Ophthalmology Academy for new videos. Thank you.